The deadliest predator to ever walk the earth was not a saber-toothed cat with 7-inch canines, not a short-faced bear standing 12 feet tall, not a pack of dire wolves closing in on a frozen plain. It was, and remains, an insect smaller than a fingernail, the mosquito. Throughout the entire span of human history, mosquitoes have killed more people than every war, every genocide, every plague, and every famine combined. The math is so staggering, it almost sounds fake, but it is not. Malaria alone has claimed somewhere between 50 and 60 billion human lives across the centuries, and that is just one of the diseases these insects ferry from vein to vein like biological taxis. So here's the question that should keep you awake at night, and not just because something is buzzing near your ear. When early humans slept out in the raw wilderness, without netting, without chemical sprays, without the luxury of a screened porch or a can of DEET, how did a single night in a swamp not result in absolute biological execution? How did our ancestors, huddled around fires in river valleys thick with humidity and rot, survive long enough to become us? The answer is not simple. It is not one trick. It is a layered, brutal, millions of years arms race that reshaped human behavior, human chemistry, and even the fundamental structure of human blood. To understand the scale of this war, you have to first appreciate what early humans were walking into. Imagine a Pleistocene river delta at dusk. The temperature drops just enough for the air to hold every molecule of moisture like a wet blanket. The water is stagnant, warm, and absolutely teeming with mosquito larvae. As the sun vanishes, the swarm rises. Not a few mosquitoes, not a cloud, a wall. A living, vibrating curtain of insects so dense that it can literally asphyxiate large animals by clogging their nostrils and throats. This is not hyperbole. Modern cattle in northern Canada and Alaska still die this way when Arctic mosquito hatches reach their peak. A caribou can lose half a liter of blood in a single day. Now picture a human, no fur coat, no thick hide, just bare skin, sweat, and a nervous system finely tuned to detect the faintest touch. Early humans were, from a mosquito's perspective, a walking buffet with no cover charge. Soft skin, thin dermis, exposed capillaries, and a body temperature that advertised warmth and life like a neon sign in the dark. We were the easiest target in the ecosystem. And yet, we are here. That fact alone means our ancestors did not just endure this nightmare. They cracked it. They hacked the system. They found ways to survive in an environment that was, quite literally, trying to drain them dry. The first line of defense was not intellectual. It was observational. Early humans were apex learners, not because they had textbooks, but because they had eyes and time. They watched the animals around them, and they noticed something that seems obvious only in retrospect. Large mammals like elephants, buffalo, and rhinoceroses did not just stand in the sun for fun. They wallowed. They coated themselves in thick, viscous river mud until they looked like statues made of clay. And when the mud dried, it formed a secondary skin, a brittle, cracking armor layer that a mosquito's proboscis simply could not pierce. The physics are elegant. A mosquito's feeding needle, its fascicle, is a marvel of microengineering. It is flexible, serrated, and capable of sliding between pain receptors to avoid detection. But it is also delicate. It cannot punch through a quarter inch of packed clay without bending, breaking, or clogging. Early humans watched this, experimented with it, and adapted it. They began covering their own bodies in mud, clay, and eventually rancid animal fats. The fats were the crucial upgrade: mud cracks and flakes. It falls off with movement and sweat, but fat is persistent. Rendered animal fat, left to go slightly rancid, becomes a sticky, semi-liquid barrier that clings to skin for hours. It seals pores. It masks the carbon dioxide plume that humans exhale. The primary homing beacon mosquitoes use to locate targets, and perhaps most importantly, it smells. To a human, rancid fat is disgusting. To a mosquito, it is olfactory chaos. The chemical signature of decaying lipids interferes with the insect's ability to parse the specific cocktail of lactic acid, uric acid, and ammonia that human sweat emits. Our ancestors walked around smelling like a butcher shop dumpster, and it saved their lives. This was not a perfect solution. It was itchy. It attracted other parasites. It probably caused skin infections. But it worked well enough to buy another sunrise. And in evolutionary accounting, that is the only ledger that matters. But mud and fat were not enough for the worst nights, the peak hatches, the moments when the swarm was so thick that visibility dropped and breathing became a conscious effort. For that, early humans turned to fire, and they turned it into a weapon. This is where the story gets genuinely clever because our ancestors did not just use fire for warmth and cooking, they weaponized its chemistry. They discovered through millennia of trial and error that not all smoke is created equal. Burning plain wood produces some deterrent effect. The carbon, particulates, and heat confuse mosquito thermal receptors and clog their breathing spiracles. But certain plants, when tossed into a fire, create something closer to a chemical force field. Toxic leaves from plants like wormwood, eucalyptus, and neem release volatile organic compounds that are outright insecticidal. Pungent grasses, crushed in green, emit smoke rich in compounds that disrupt mosquito nervous systems. Green pine needles, heavy with resins and terpenes, burn inefficiently and produce thick, acrid smoke that hangs low and creates a protective bubble around a campsite. Early humans did not know the molecular names for these compounds. They did not need to. They knew that when the green needles went on the fire, the buzzing stopped. They knew that certain tribes in certain valleys had access to plants that made their camps livable, while neighboring groups were driven to madness. This knowledge was passed down as oral tradition, as ritual, as survival lore so sacred it was probably indistinguishable from religion. The fire was not just a tool, it was a fortress, and the smoke was its moat. There was also the matter of geography as strategy. Early humans were nomadic, and their movements were not random. They followed the herds, yes, but they also followed the seasons of suffering. Peak mosquito activity correlates directly with temperature and standing water. The worst swarms emerge after spring thaws and during the wet seasons when floodplains expand and every depression becomes a nursery. Early human bands learned over countless generations to read these patterns. They moved to high ground ridges during the worst months. They avoided river valleys at dusk. They camped on exposed, windy promontories where steady air currents made it physically impossible for mosquitoes to land and feed. Wind is the mosquito's natural enemy. These insects are light. A breeze of just a few miles per hour can ground them entirely. Our ancestors sought out the wind like sailors seeking favorable tides. They paid for it with colder nights, less shelter, and harder terrain. But the alternative was to be eaten alive in the lowlands. This was not comfort. This was triage. This was the calculus of survival, and it shaped human migration patterns in ways we are only now beginning to map through archaeological evidence. The ridges and highlands where we find ancient campsites were not just chosen for defense against predators or access to game. They were chosen because they were the only places a human could sleep without being drained. Now we arrive at the deepest, darkest layer of this story. The genetic compromise, the biological surrender that proves just how relentless this war truly was. Because physical defenses and behavioral adaptations were not enough. The mosquitoes were not just biting, they were infecting. They were injecting biological malware directly into the bloodstream, parasites that hijacked human cells and used them as factories for their own reproduction. Malaria is the crown jewel of this parasitic empire. The Plasmodium parasite enters the blood through a mosquito bite, invades the liver, multiplies by the thousands, and then bursts back into the bloodstream to consume red blood cells from the inside out. It is a masterpiece of evolutionary cruelty. And human populations that lived in malaria zones for long enough did not just adapt their behavior, they adapted their biology. They changed the very shape of their blood. This is where the story becomes almost too brutal to believe. The human genome, under the crushing selective pressure of mosquito-borne disease, deliberately malformed its own red blood cells. It created sickle cell trait. It created a genetic condition in which red blood cells collapse from flexible discs into rigid, curved crescent shapes. These sickled cells do not flow smoothly through capillaries. They clump. They jam. They starve tissues of oxygen and cause episodes of excruciating pain. In its full expression, sickle cell disease is devastating. It shortens lifespans. It damages organs. It is, by any reasonable measure, a terrible affliction. But here is the evolutionary kicker. Those sickled cells are a hostile environment for the malaria parasite. The parasite needs healthy, plump, oxygen-rich red blood cells to complete its life cycle. The sickled cell is too deformed, too fragile, too chemically altered to support that replication. A single copy of the sickle cell gene, the heterozygous state, reduces malaria mortality by roughly 90%. The trade-off was grotesque but mathematically sound. The human species accepted a painful, debilitating genetic disease as the necessary cost to survive a microscopic enemy delivered by an insect. This is not a happy story of adaptation. This is an evolutionary hostage negotiation. The genome paid ransom in the currency of human suffering, and it paid it for thousands of years. And sickle cell is not the only receipt. There is also thalassemia, another blood disorder that reduces hemoglobin production and makes the cellular environment less hospitable to parasites. There is the Duffy antigen negativity found in many African populations, a complete deletion of a surface protein that the malaria parasite uses as a molecular door handle to enter red blood cells. There is glucose 6-phosphate dehydrogenase deficiency, which causes red blood cells to break down under oxidative stress and, as a side effect, dumps the parasite out before it can mature. Each of these conditions causes real harm to the people who carry them. Each is a scar. Each is evidence of a war so old and so vicious that the only winning move was to damage your own biology enough to become an unlivable habitat. And the war was not just against malaria. Mosquitoes are the primary vectors for yellow fever, dengue, Zika, West Nile, chikungunya, and a parade of other pathogens that have shaped human history in ways we rarely acknowledge. The genetic footprints of this conflict are still visible in modern human DNA. Populations from mosquito-dense regions carry allele frequencies that reflect millennia of selective pressure. Your blood type might influence whether mosquitoes prefer you. Your body odor chemistry, shaped in part by genetic variation in the HLA complex, determines whether you are a mosquito magnet or a mosquito ghost. Some people genuinely are bitten less, not because of any product they use, but because their ancestors won enough genetic skirmishes to alter their metabolic signature. You are, right now, carrying the cumulative survival strategies of ancestors who slept in mud, choked on smoke, and bled in the dark. Every time a mosquito ignores you at a summer barbecue, you are experiencing the echo of a victory paid for in pain. But here is where the narrative takes its final cynical turn. Because we did not just survive the mosquitoes, we escaped them. We built concrete cities with sealed windows and air conditioning. We drained the swamps and paved the floodplains. We synthesized DEET and permethrin and deployed them like chemical armies. We declared victory, moved indoors, and forgot the war ever happened. And in doing so, we made ourselves fragile. The modern human immune system, raised in sterile environments and shielded from constant low-grade pathogenic exposure, operates like a soldier who has never seen combat. It is jumpy, prone to overreaction, confused by harmless allergens, and increasingly unable to handle the threats that do slip through. We eradicated malaria from the temperate zones and then pretended it was a problem of the past, even as it still kills 600,000 people every year, mostly children under 5, mostly in Africa, mostly because they do not have the luxury of screened windows and pharmaceutical supply chains. We built a world where the buzz in the dark is a nuisance rather than a death sentence, and then we exported that world unevenly, leaving billions to fight the ancient war with ancient tools while we complain about a few itchy bumps. And yet the mosquitoes are still here. They are adapting. Climate change is expanding their range, pushing tropical species into formerly temperate zones that have no immunity, no genetic defenses, no cultural memory of how to survive the swarm. The Aedes aegypti mosquito, carrier of dengue and yellow fever, is establishing itself in southern Europe and the southern United States. Malaria parasites are developing resistance to our frontline drugs faster than we can develop new ones. We thought we had built a fortress, but we built it on the assumption that the enemy would not learn to climb. They are climbing. They always climb. They have been climbing for 100 million years. So what is the final accounting? The human species survived mosquitoes not through any single genius invention, but through a layered, redundant, often brutal toolkit of behavioral hacks, chemical warfare, geographical strategy, and biological self-sabotage. We watched animals and smeared ourselves with mud. We burned the right plants and choked on the smoke. We fled to windy ridges and shivered through the night. We let our own blood become deformed and diseased to poison the parasites within it. We paid in discomfort, in shortened lives, in genetic scars that still mark entire populations. And then, a few thousand years ago, some of us started building walls thick enough to pretend the war was over. But it is not over. It will never be over. Every human alive today carries the survival instincts and the mutant blood armor of ancestors who fought a millions of years old war against the buzz in the dark. The next time you hear that high-pitched whine near your ear in the night, understand that you are not just annoyed. You are being visited by the oldest enemy our species has ever known, an enemy that has killed more of us than we have killed of each other, an enemy that forced us to change our skin, our smoke, our camps, and our very cells, and an enemy that is still waiting, in the stagnant water and the humid dark, for us to forget how to fight.